We shall investigate the investigation. Suppose, instead, we have rectangles of single size 3 by n for some integer n greater than or equal to 6. Placing them on the grid as above, what is the largest integer n for which it is not possible to cover exactly n unit squares? So, basically same problem as 10, but replace 5 by 7 by 3 by n. We break it up into two cases. N is 1 mod 3, n is not 1 mod 3. If n is 1 mod 3, I claim the answer is 4n minus 1. First, I'll prove anything bigger than 4n minus 1 is possible when n is 1 mod 3, when n is 1 mod 3. Because 4 times 2 mod 3 is 2 mod 3, and 2 mod 3 plus 1 is 0 mod 3, so we can also get 4n plus 1. Now we can also get, now I need to show we can get 4n plus 2.
We can add 3, like this.
Yeah. 4n plus 1, because it's divisible by 3. Because n is 2 mod 3. Now to get 4n plus 2, what we do is we do the... Let's see. How much is this? Yep. 1, 1. Oh, 3, yeah, 1, 1, 1.
So that's how you get 4n plus 1.
Because n is 2 mod 3. Alright, now we are showing this case. So now we're getting 4n plus 2. You see this is a construction for 4n plus 2?
So this is 3. How much is
this is 3, this is 1, this is 1, so it's like with 2 squares there, n squares here, so it's 4n plus 2.
Okay, so this is 1, 2, 1.
So now we have constructions for...
Wait, so
4n
left-hand side is 1? Okay.
Yeah, so it's 1. So now I have constructions for 4n minus 1, for 4n, 4n plus 1, and 4n plus 2.
I don't understand. Well, what is this picture? So it's like...
It's like
3 by
shift
n
it.
rectangles?
Yeah, but we shift it, we have 1 and then we shift the other 1 across and 1 up.
1 across.
1 up. Yeah, like Gregory is trying.
So how many squares up?
4n plus 2. Because this is up here, that's n. Yeah.
Oh wait, so n is 2 mod 3.
So then we have 1, 2, and 3 mod 3. So then what we can do in all of these cases, right, we can keep adding 3. So we can get everything greater than 4n.
Okay.
Alright. Now we want to prove we can't get 4n minus 1. Alright. Then we have a bunch of cases. So first, it's called move this. Move this. Alright, so obviously 4n minus 1 is not divisible by 3. Also not attainable by adding like 3's to 3n. Because you need to have at least a 3n by 2n. We cannot attain it with a rectangle. We cannot obtain 4n minus 1 with a rectangle. So we also cannot obtain it with anything where the where the long lengths, the n lengths are parallel, right? Because then we have at least this case, which is at least 4n plus 2. Isn't achievable for 4n minus. So we cannot have them be parallel at all. So now let's suppose they're not parallel. So we have a bunch of cases. Firstly, if it's directly like this, how many do we get? Well, we get 4n minus 9. Alright?
Wait, what? This is it.
Wait,
this
no.
one plus
No, this we get it way more. We just get a lot.
This one plus
So,
this
what's
one.
it called? This one we get 6n minus 9. Because n is greater than 6. Let's see.
This is 3n.
Because n is greater than 6. 9 9 is smaller than 2n, right? So then that's bigger than 4n. So then we know we cannot achieve 4n minus. So then
this
we know
is
we
like
can't achieve 4n
6n
minus 1.
minus 9.
Saying if it's 0.
2 mod 3.
Oh, wait, no. Sorry, 2 mod 3. Yeah. When it's 0 or 1 mod n, mod 3, then it's 4n plus 1. Alright, so first I'll show anything bigger than. I'll show 4n plus 2, 4n plus 3, and 4n plus 4 are all achievable. So what we do the same overlapping construction, right? Gets us 4n plus 2. Then what we can do, we can fill in the corners one at a time to get 4n plus 3 and 4n plus 4.
Oh, okay.
Then we can add 3 to each of those so we can get anything bigger than 4n plus 2 by the mod. Alright, so now what I'll do, alright, now I'm going to erase this. Now we'll show it's not possible for 4n plus 1. Alright, so let's consider first what happens when it's a rectangle. If it's a rectangle, we can only add 3 or n, right? We have to add at least either 3 or n. So what we first know is, suppose it's a rectangle, if it's possible to get 4n plus 1, we know we can't have added an n length edge. So we know it can't be 4 by n, right? Because 4 by n is 1 minus 4n plus 1, so it's not achievable if we have a 4 by n rectangle. So then we have to have it's like 3 by k for some k. But that 3 by k, right? And so we know that it has to be 3 by some k, which achieves 4n plus 1, right? Because we already have 3n at the start, so we can't go adding any lengths of n at some point. So then it has to be 3 by k. It's not possible because 4n plus 1 isn't divisible by 3. Now let's look at non-rectangular. So obviously it can't be parallel for the same reason as before, because we once again get 4n plus 2 when the long lengths are parallel. So now we look at the other case. Once again, we get the same thing. It's bigger than 4n plus 1 because this is 9. Yeah, 4 or 9. And yeah, it was minus 9. So it's 6n minus 9. N is greater than 6. So it's bigger than 4n plus 1.